We're going to begin our lesson by just doing a review of the square root method. So because I have my x inside the parentheses, I'm going to go ahead and try to do reverse PEMDAS, starting by adding the 1 and then dividing the 2. And we're just going to leave it in fraction form. We don't want decimals. So then I need to remove the exponent next, and we're going to do that by square rooting both sides. Now when we square root a fraction, we want to root the top and we want to root the bottom. And because we created the root, it wasn't already in the problem, we need to write plus minus. All right. So before I move this 3 over, I don't want to have this root in the bottom, so we're going to rationalize. We're going to times root 2, top and bottom, and get root 14 over 2. And then we're just going to move this 3 to the end by subtracting it, and that's my answer. We just leave it just like that. Now, when we see a problem like this, that technique is not going to work. The reason it's not going to work is because I have an x squared term and I have an x term. So I can't combine them because they're not like terms. I can't just add them together. If I get the x squared term alone, well, then I'll have an x on the other side. And if I get x alone, then I'll have an x squared term on the other side. So I can't get one of them alone. It's not going to work that way. So reverse PEMDAS isn't going to help me here. So we're going to need another technique. And today that technique is called the quadratic formula. All right. This is just the square root method that's rewritten in terms of A's, B's, and C's. So mathematicians worked this out for you so that it saves you a lot of time and effort. You could solve this if you put it into vertex form. So I could have you compute H, and then I could have you compute K, and I could have you rewrite it in this format. And then you could use the square root method. That would take a very long time to do all that. So mathematicians kind of already did that for you and presented the answer in means of a formula using A's, B's, and C's. Since this is in standard form, you have an A, a B, and a C. So that quadratic formula takes advantage of that to make things easy for you. So it looks scary right now, but once we write it over and over, it's going to become very easy. All right, so it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we do have to memorize this formula. A lot of colleges, professors prefer that you have it memorized, and truth be told, it makes your workload so much quicker if you do have it memorized. It takes forever if you have to keep going back and looking it up. So I have a little trick that I like to use. I didn't create this, but I use it all the time. So it's the quadratic formula song, and it kind of sounds like Pop Goes the Weasel. It goes negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll just keep singing that song over and over when I set up my quadratic formula, and then in no time, it's just memorized. It's ingrained in you. Now this part right here, the stuff that's under the root has a special name, and that's called the discriminant. So I'm going to use that word a lot just because it's quicker than saying, do the stuff that's under the root. I can just say, get me the discriminant. And it's easier for communication purposes. So there's a new word for you. All right, so we have our quadratic formula here, and we're going to go ahead and get ready to use that. Now it's important to note that there is a 1 in front of x squared. We just typically don't write it, but it is there. So we have an A, a B, and a C because this is in standard form. So we have A, B, and C. So we're going to take those numbers and we're going to put them right here in our quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And you'll notice I put parentheses around all the numbers that I substituted into this formula. Sometimes you can get away with not using parentheses, but it's better to play it safe and just build that good habit. So I'm going to use them. All right, so that's step 1. You just want to set it up. That shows your teacher, oh, I know what the formula is, and I knew where the numbers went. The next step is we're going to take the discriminant and we're going to type that right into a calculator. So this is where you take out your calculator and you would type in it parenthesis 5 squared minus 4 parenthesis 1 parenthesis 8 and hit enter. Don't type the square root button. Don't hit that. Okay, don't want to do that. That'll turn your answer into a decimal. We don't want decimals. So you're going to get -7. So you're going to rewrite this problem, -5. We have 2 on the bottom, and we have -7 in the root. So already the problem looks a lot cleaner. It looks a lot simpler just because the calculator took care of all that inside stuff for me. Now I'm going to look at my root because our root should always be simplified. You can't leave a negative in a root. So we're going to pull the negative out and replace with an I. So my final answer is -5 plus or minus I root 7 all over 2. And we just leave it just like that. Now in number 2, you'll notice that I only have A and B. This guy over here, he's on the wrong side. So one of the rules of the quadratic formula is the problem has to equal 0. So this -1 needs to come over here, and we're going to do that by adding it over. So now I have my A, my B, and my C lined up. It equals 0. I'm clear to use the quadratic formula. So we're going to start plugging the numbers in. And you want to be careful because in this one, B is actually -4, not 4. And it's always plugging in negatives where I see the most mistakes. So we're going to go ahead and set it up. -B plus or minus the square root of B squared minus 4AC all over 2A. You can see I put everything in parentheses that I substituted. Then I'm going to type my discriminant into my calculator, again, not hitting the root sign. 4 squared minus 4 times 4 times 1 is actually just 0. So I'm going to write root 0. This becomes 4, and down here becomes 8. Now the square root of 0 is just 0. So I'm going to write 0. Now 4 and 0 are like terms. You can actually put them together. So instead of leaving my answer like this, I'm going to break it into 2 problems. I'm going to use the plus sign for one and the minus sign for the other. So I'm actually going to use the positive negative symbol and break it into 2 cases. 4 plus 0 over 8 is a half, and 4 minus 0 over 8 is still a half. So either way you cut it, you get 1/2. You're only going to get one answer to this problem. The reason you're only getting one answer to this problem is because 0 is a very special number. There's no difference between plus 0 and minus 0. So any time that your discriminant is 0, you're only going to get one answer. Anything else, you're going to get 2 answers, but when 0 is your discriminant, you're only going to get one answer. And that's because there's no difference between plus and minus 0. Now, we're going to make number 3 just a little harder. I'm going to put some fractions in here. All right. We don't want to use fractions in our quadratic formula. That would be awful. So my suggestion would be multiply all of these by 12, because that'll make your 12 and your 3 go away. So when I do that, here's my new numbers. Then I'm going to take this minus 12 and I'm going to bring it over here by adding it so that the problem equals 0. And now I can set up my quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. All right, then we're going to type in our discriminant. And again, you have to use these parentheses. If you don't, you are going to get it wrong. So it should come out to -32. Regular 4 and 2. Again, I can't divide 4 by 2. The reason is there's nothing out here that's divisible by 2 as well. So all 3 of these items have to have something in common, and they don't. But I can break down 32. That is 4i root 2. Now I have a 4, and a 2. Now I can divide by 2. So my final is 2 plus or minus 2i root 2. So if you want, you can pause the video and try number 4. We want to get rid of the fractions first, and then move everything over, and then use the quadratic formula. So if you want to try it on your own, you can pause it, give it a shot, and then unpause it to see if you did it right. All right, you can take a look. The first thing to make sure is that your numbers are correct, that you did actually get 9, 6, and 11, and that the signs are correct as well, because if those are incorrect, then everything else is going to be wrong. All right, and then you would check your discriminant. Did you get 432? Did you type the buttons on the calculator correctly? 432 breaks into 144 and 3, so that will become 12 root 3. And then all of these have a 6 in common, which is how I get to my final answer. There's 2 more problems here that you can certainly try. If you want, you can pause the video, give those ones a shot, see if you have a better handle on those, and when you're ready, you can unpause it and see how you did. Okay, so for number 5, you want to make sure that you used 3 and negative 40 in the problem. Then check your discriminant and see if you got 169. That is actually a perfect square. That's 13. So because these can be combined, you have to use the plus symbol, get an answer, and then use the minus symbol and get an answer. Negative 3 plus 13 is 10, and 10 divided by 2 is 5. Negative 3 minus 13 divided by 2 is negative 8. All right, and then over here, number 6, I would have multiplied everything by 8 to get rid of both of these, the 8 and the 2. You should get 4, 4, and negative 9 to use in your formula. And then the rest kind of goes from there. So in our next video, we're going to take that quadratic formula and use it to solve some word problems, and I'm going to teach you some phrases and what they mean as well.